Welcome back to this channel. In this video, you are going to learn about iterators, iterable, and different ways of creating iterators. To begin with, what is iterator in Python? Iterator is nothing but an object representing a stream of data that keeps state or position in the stream. It has both iter and next method. It does the actual work of returning the next value via next method and writes stop iteration exception when there is no more data in the stream. What is iterable? Iterable is an object that can be looped over. This can be list, tuple, string, dictionary, set, file, or any custom class with iter method. So let us see the main difference of iterable and iterator. Iterable is nothing but an object with iter method. Right. Iterable is an object with iter method, whereas iterator is an object with both iter and the next method. Iterable can be looped over. Similarly, iterator can also loop it over, but pause and resume fashion is there. The other thing, iterable cannot track of position, whereas iterator remembers current position. So in short, iterable, think of it as a container like list that can be looped over, whereas iterator, think of it as the tool that pulls out one item from the container at a time. So let us proceed to the ways of creating iterator. We do have different ways of creating iterator. What the simplest way is using iter function. Iterator can be created using this built-in function where it takes iterable object and returns iterator. What the second way of creating iterator is using custom-iterator through the iterator-protocols. Right? You can define your own custom iterators by creating a class that implements next and iter methods. The third one is iterator can be created using generators. Generator using function or generator using expression. What's the other way of creating iterator is nothing but using iter-tours module. Right? So let us see one by one. When we begin with creating iterator using iter function, first we need to have, for example, list, my list 2 3 4 5, right? My list consists 4 elements. Let me run. Then what's the interest here is to create an iterator from this list using iter function, which is built-in function. Therefore, let me name my iterator, then iter takes iterable object, in this context my list, right? Therefore, let me run. Now my iterator is an iterator, whereas this one is an iterable, but this one an iterator. So let me print one by one what is there in my iterator. Before that, let me check whether this my iterator is really an iterator. Let me print this one, iterator. Well, this one is nothing but an iterator with this memory address, right? But this iterator came from list object using iter function. So let me print every item in my iterator using for loop, because my iterator is an iterator which can be looped over, right? For I in my iterator, right? Print every I. Wow, this is nothing but 2 3 4 5. The other way of printing these elements using next method or next function. Print because iterators have next method, right? We can print my iterator one by one iterator, but before running this one I have to reinitiate this one, right? Because we have run these elements using for loop, right? So let me run this one. The first element of the iterator is printed. If I run again this statement, the next element will be printed. If I request to display the next element next to 3, 4 will be printed, then 5 will be printed. No element beyond 5 in our iterator. So what will print this statement? That is nothing but the stop iteration exception. That tells us that there is no more data in our stream or in our iterator. What's the other way of creating an iterator is using custom class iterator. This can be created. We can create an iterator using iterator protocols, meaning that we create a class which is an iterator class using iterator protocols. What are those iterator protocols? Are nothing but the next method and the iterator method. For example, class square iterator, right? This iterator class generates the square of some squares, limited squares, right? The square of 0, square of 1, square of 2, square of 3, and extra. So let us see how can we create such iterator by creating class, custom class. So class takes if init self is the first argument, then max, then self max aside max, then self I, which is the current position, 0. But this is nothing but a state which signifies current position of the iterator, which later can be updated, right? Okay, right. If iter then self, right? This is special method which is called iter method, which returns the object itself, right? Which returns self, right? What the other method here is next, no, self, right? Within this next method, we expect to have the next element of the iteration, and we can also check whether the iteration reached at its maximum limit or not, and the position can also be updated here within the next method. Now what the first step is to check whether the iteration reaches its maximum limit. Let me check if self I greater than or equal to the max. No, self max, right? If this iteration process reaches its maximum level starting from 0, then rise stop iteration, right? Stop iteration. Otherwise, continue calculating the square iterator, meaning that result I2, right? But we don't have I variable here, we do have self I, right? Then we update the position I, or the counter, update self self I 1, right? Then return result, right? Let me run success, right? Now let me add illustrations. This is nothing but state which is current position of the iteration, where this one is iter method which returns the object, iterator object itself, right? This one is next method which returns next value of the code, right? And this one checks if maximum has reached, right? Because the iteration goes from 0 to the maximum. So this line or this statement checks whether the iteration reaches its maximum. If so, tries stop iteration exception. Otherwise, calculate the value to return, right? To return. And the next one, update the counter or position to the next value, right? Then this statement returns the value, the calculated value, right? So this one is custom iterator, which is created by creating custom class. So let us instantiate this object, right? What this object does is squaring each element is from 0 to certain maximum value, right? Let us instantiate that example squares. The squares is object now, which is squares iterator of the maximum 5, right? Let me run. If so, right? No spelling error. This one, right? The maximum is now 5, which can be passed through this init method, right? When this object is executed, immediately this init method is to be executed, right? So now this object is created, squares object. Now this squares is an iterator. Let me check squares run. This is nothing but an iterator which is named by square at main module and with this memory address in our machine. So let me print each element where each elements are the squares, right? For j in squares, right? Squares print every j. What this prints the square of each element in our iterator, right? What the counter is 0, 1, 2, 3, but this class iterator does squaring of each these squares, right? So this is nothing but the first element of the squares is 0, 0 square is 0. Second one is 1, 1 square is 1. Second is 2, 2 times 2 is 2, right? And as this squares object is now an iterator which is created using square iterator class, we can make use of the next method to print each item or each number, square number, right? Using next method, squares, right? So this next method is useful for retrieving the elements of the iterator by printing and pausing, right? Or yielding and pausing, right? Now the first let me reinitiate this one before running, because we ran this statement, right? So let me run this one, right? But the first element to be printed using this next method is 0. If I repeat this statement, no, this statement here, what is to be printed? The next element, which is 1, right? The next is 4, right? So this is nothing but this object due to this class is now created an iterator. What's the other way of creating an iterator is using generators, right? 3. The third way is 3 using generator function, for example. Generator can be created using function or expression. Let us see the same task using generators, meaning squaring each elements of the squares. For example, now if square gen, right, that takes an integer, then the integer is initialized from 0 while this I is less than yield. Recall that generator make use of yield instead of return. Yield what? I square, right? Then I updated by 1, right? This is nothing but a generator which produces an iterator object, right? Now let us instantiate an object, squares, right? Let me take this one where n is now 5, right? Let me run, right? An iterator object now is created, which is named sq. Now for I in sq, print I, right? This is nothing but 0, 1, 4, 9, 60, right? Let me check whether this one is an iterator, right? Sq is nothing but generator object square gen at the memory address of this one. It is a generator object. Generator by default is an iterator. For example, let me check whether these elements are printed through next method, because an iterator has both iter and the next method. Print next sq. Wow, let me reinitiate this one, right, and this one. Now let me check this one. The first element is now to be printed using this one. Wow, right. And let me repeat this one statement to print the next element, which is now 1. Let me check the next 4, right? Generators are iterator. Similarly, to remove this 25, we can remove this one, right? Let me reinitiate this one, then run this one, right? This is nothing but 01496, similar to the previous one, this one. Similarly, let us do or create an iterator using generator of expression type. For using generator expression, right? For the same example, right? For example, sqe, this is similar to list comprehension, but it makes use of this opening and closing parentheses here. Now x times x for x in range 5, right? 1 closing parenthesis. Now sq is a generator which is created using expression generator. Sqe prints as it is generator object, right? Using generator expression, occupy the space by this memory address, right? Now for I in sqe, print what? I, every I, right? 0, 1. But the other way of creating iterators is nothing but using iterators module. This iterators module in Python is a treasure chest of fast, memory efficient tools for creating and working with iterators. It is part of the standard library and is especially useful for looping, filtering, and combining data in elegant ways. So in this particular example, let us see how to generate the previous task, meaning generating the squares of each numbers from 0 to 4. So for I in iters dot count 0 to 1, where this 0 to 1 is nothing but 0 is the start, whereas 1 is step, meaning the distance in between two consecutive numbers, where this count is a method within iterators module. This creates infinite iterator, right? But we stopped it by this if I greater than 3 condition, right? Stop iteration. So this for loop generates from 0 to 60 due to this competition formula for every I in iterators count 0, 1, 2, 3. But beyond that, iteration break. Let me run this one. Right. This result is 0, 1, 4, and the same result with the previous example. But what the method we have used is iterators module to generate these squares. Thank you for joining me on this learning journey. We have reached the end of this tutorial, and I hope it brought you valuable insight and practical skills. If you found this helpful, don't forget to subscribe, leave a comment, and share your thoughts. Your feedback helps improve the channel and better serve our learning community. Thank you for watching.